In the last video, I finally got the Control ROM working where it was copying and everything was testing out okay. I even got into the PCB layout and got all the components placed. I'm going to start right where I left off and get right into putting in the traces associated with that. And then I'm going to get into the Control ROM Control and do the same breadboard cleanup, schematic cleanup, and then hopefully I can get into its PCB layout as well. Let's get right into that.
Hi, I'm Adam. I'm still building a 16-bit computer from scratch. I'm no expert here. I make lots of mistakes. So many mistakes I've actually had to reboot my computer build. I hope you will find my journey interesting, and I hope you will join me as I learn along the way.
Okay, here's where we left off in the last video with the PCB layout. You can see I've got silk screen that's running off the edge of the board. I've got fabrication markings which run off the edge of the board. I've got things that are overlapping. But what I really want to deal with first is simply the traces. I really want to get these laid out and make sure that everything's actually going to fit before I start into the silk and the fab markings. Now this is going to be a 4-layer board. So the outer two are going to be signal layers. Right underneath the top or front copper layer is going to be the ground, then VCC below that, and then of course the bottom layer. And really it's just a matter of getting in here and putting all the vias in and writing all these traces. I think I'm in good shape here, but time will tell. I actually started with the easy traces first because it's been quite a while since I've worked on a PCB. I had to get used to the shortcuts and the keystrokes again. Okay, one of the signals I'm worried about most is down here, this copy clock. I want to have that one actually encased in ground vias and traces. Okay, I made a mess of this, so let's see if I can clean it up. Okay, the other one I want to deal with is the copy clock here, which I think I can put on the top. Why am I going through all this fuss with the traces in order to make sure that they are encapsulated in ground? Well, very simply, it's because I understand that that actually gives me the best insulation for high-speed signals. Now, it's not like I've got megahertz signals here on this board, but what I do have is potentially fast rise times, and that's what I'm worried about here. All right, that's probably the fussiest part of this whole thing. Okay, I'm going to flop those 3 around and see if I can't get a better situation here. Okay, so those 3 are going to get swapped with those 3. Okay, and that puts these over here, so let's see here. OE, output enable and write enable need to be swapped. Okay, that's routed. All right, I'll tell you what I'm going to do. I'm going to route in here, basically in the ground layer, all the ground connections. Okay, that interconnects everything. Everything's routed. Let's do an electrical rules check, or design rules check, excuse me. Well, silk screen's going to be a problem. Let's go to the error. Okay, that takes care of all my errors. Now let's see what we can do with the silk screen. I think I like the way this looks. Yeah, actually, I did find one mistake, so let me see if I can get that fixed. Okay, that's much better now. The next order of business here is going to be to export the Gerbers and inspect those. And I've been caught out on this a couple of times. I do want to make sure that everything actually looks correct before I zip that up and send it off for fabrication. So I just exported all of that. Let's open it up and take a look here. So let's start with the top copper. So what am I looking for here? I've got all of these. Oh, okay. So I've got all of these traces here that are coming next to existing ground plane or vias or through holes or what have you. And I want to make sure that things actually look good. Now, if you recall, I had these signal traces that were ultimately routed so that they were encapsulated or bounded, if you will, by ground signals. And if you look closely here, and I'm hoping this comes up all the way through on the video, there's a hairline difference between the actual trace and the fill. Well, that's not going to work because as I understand it, the chemicals that etch the copper off the board are going to get caught in there and cannot be reliably cleaned away. So I need to come up with a different method for doing this and still have enough room to do all the different things I need. For example, this trace here, I want to make sure gets pulled over so I've got room to ground fill here. So that's going to take a little bit of work to clean up. All right, let's take a look at some of the other layers. The bottom copper, I don't believe has the same, yeah, it does have the same problem here. So this was the one that I put on the ground, and that's also going to be a concern. So I might have to shift that over around a little bit just so I can get things to work properly and have enough room to ground fill. Okay, what about the internal layers? So let's see here. Internal copper 1, this is the ground plane. There may be something here that looks like it's encroaching a little bit. I'll have to take a look at that. And then the VCC. That actually doesn't look too bad too. Oh, no, I've got a spot right here. I've got a trace that goes through the setback for a through hole. So there's something there that needs to be cleaned up. Now you're asking, Adam, why didn't the design rules checker pick that up? That's a great question. I don't know that I have an answer to that other than since I started this project and today, this project being the 16-bit computer from scratch, I have updated to KiCad 7. That may be a bug. I don't know. Yeah, I have no idea, but I'm going to pull that out and spend a little bit of manual time on this. So like I said before, I've been caught out by not reviewing the Gerbers before sending those off for fabrication. Prior, it was related to me not getting the silk screen right. You know, this time I found something that wasn't necessarily completely in my control. Okay, let's start with the inner layers. Okay, this one's a via next to a via. That one looks like it's legitimate. There's a trace I can just pull down there. So that's VCC. Let's rebuild that just to make sure. Okay, let's got another one up here and up here. Now let's go to the back copper. Okay, I think that's probably going to be the best I can get that. I might be able to pull this way just a smidge, and that might help as well. Okay, now for the top layer. Okay, I think that's probably going to have to do. I think I need a bigger trace here, though. All right, let's run some design rules checks and see what I broke. One unconnected item. Okay, let's re-export those Gerbers and see if that makes a difference. All right, so front copper, back copper. That's that spot I just added. Ground layer, that was acceptable. VCC layer, and that's all cleaned up as well. All right, now let's take a look at the silk screens. Now prior I also put a round spot here and here to help denote pin 1. I don't believe I need that anymore because the line here is actually pretty prominent on the PCB's front silk screen. This doesn't have the line, it's got the asterisk there to denote pin 1. I'm not sure exactly what these markings are. No non-plated through holes. That's a good sign. Plated through holes. Couldn't tell you if that's good or not. Okay, well, I think that looks good now. The next thing to consider now is I have actually changed the location of several of these signals up here. Now, the first two from the left come all the way over here to the EEPROM, which is just off the left of the screen. Recall that they were fished in the gutter down the center of the breadboard. Those two don't move. The next three, on the other hand, do get relocated, and they're down here on this end of the 16-pin connector. These three get moved in place and they get shuffled. So for me to actually make this match the schematic, I have to pull everything out and redo these connections. Is this a big deal? It's working now. Is it a problem that the breadboard doesn't exactly match the schematic? I'm fighting my OCD on this one. Part of me wants to say, yeah, it matters and I should make it match. Part of me says, lighten up, Adam. You're close enough to wrapping this up. Don't add additional work on top of it. So what are the consequences then if we move on? So if we move on, up here, I need to actually create connection points off of this Control ROM breadboard. And so to do that, I've got to move the reset over to create room so that I can drop in ribbon cables on the upper and lower. And then these temporary signals here that are all over the place, I want to pull them to here, connect the breadboards together physically, make something a little bit more permanent than these temporary hookup wires, and then jump from whatever location down here up to this location. It's nice to have a reference if I'm going to do that work, something I can refer back to if I get it wrong. But on the other hand, I'm thinking that if I just go ahead and do that work and I'm very diligent about it, I could probably get away with not having to change this unless something happened that broke it all, and then I would be forced into actually having to do that. So I think that's the path I'm going to go down. That's what I've talked myself into, at least at this point. So the first order of business here is going to be to move the switch over to give myself room. And then I'm going to start taking each one of these signals that are pulled up here pull its replacement line from wherever over to this location where it's supposed to be according to the schematic. And then I will have temporary hookup wires going from here to here just to kind of intermix everything appropriately. All right, let me get started on that. Okay, I think the first order of business here is going to be to relocate this reset switch. And I think I want to bring it out towards the edge of the board here. Okay, let's give that a test. Okay, that's working. Well, this is future Adam cutting in here. It's about 2.5 weeks later, and yes, I'm older, but definitely not any wiser. While the reset portion of this still worked, the circuit started to fall apart at this point, and I didn't catch it until I had to walk away for a little bit, and then when I came back to it, I didn't trust that things were working right when I tried to figure out where I left off. And so I spent a couple of days actually troubleshooting and resetting the circuit. It turns out that the system clock needs to be generated for this to work, and I had removed the clock module from the build, and you'll see in a little bit here I have put that back. I'm not going to cut out the work, but just know that the circuit is falling apart until I realize this. Okay, first signal is the reset signal. Next one along is reset hold. Next along is QR. QR is not used, therefore there's no need to connect it up here. So I will connect that to ground. Next along is the inverse of QR. Now that is down here. That makes its way over here to the reset signal on the shift register up here. So the part here from these 2 points is all set. I need to pull this wire over to this location. Next one along is latch enable. Next one along is the shifter enable. The next two are unused and can also be pulled to ground. Okay, that shifts me up here now to the upper rows. And the next one along is the EEPROM chip select. Now that's coming off of gate 4 of the OR gate over here. The next one along here is going to be the EEPROM command and address line. And this comes from all the way over here off this shifter. SRAM output enable. The next thing along was the output enable for the SRAM. Now, this is where things started to come apart for me, and now we're back up to real time here as I'm recording this. I ended up having to make a bunch of notes here. Basically, from this side is all related to the Control ROM module itself, and then these are the control signals coming off the Control ROM Control. And the output enable here for the SRAM has to go to pin 2 up here for the Control ROM Control module. Now, when I did that originally, several things came apart on me. First, I had removed the ESP32 and all of the test harness in order to do this work, and that was a bad mistake. When I put it back together, I had this line going the wrong direction. The ribbon cable had the bits flipped. You can see the twist in there. So I've got the least significant bit here, the least significant bit here, and when it comes over to the ESP32, the least significant bit is on the left, where typically the most significant bit would be there. I had some trouble with that before, and I'd probably had this inverted, not realizing that I had. So I made the change, and I actually plugged it into the wrong place when I made the change for output enable. So I had to go back and re-debug everything. I won't subject you to all the details associated with that. But if you look at this wire here, it does not make it all the way over to this location. It makes it to where this green jumper is plugged in. Well, let's do this right. So SRAM output enable. All right, and since I'm gun shy, I'm going to give that a test. Nice. Next up is SRAM write enable. Now that signal should be coming off of that pin there, and that is correct. So I'm going to work on getting this set here. First change is to move that there, and now I just need to run a new line. And I'm going to reuse this one because it should be just the right length for that. Now, after each one of these changes, I am going to run through a test and make sure I didn't break anything. But I'm not going to film that because I want to make sure that I am getting this all ticked and tied, but I don't want to subject you to the testing part of it because it does take several minutes in order to execute the test. Now, that said, if there is an issue, I will come back and let you know what that is. Okay, the next one along is chip enable. Chip enable is right next to the ones I've been working on up here. And that would be this line here. Now this comes all the way down here to this AND gate. So that would be gate 2 or gate B on that IC. And let's confirm that. Yep. All right, so this is my next signal to pull. Okay, the next thing along is not used, and then I've got the copy clock. Now, I've got some issues with the copy clock, and we'll get to some of those here in a minute, but this is the signal in particular that I'm talking about. And this copy clock here comes down, and I skip one because it's unused. I'm going to tie that to ground, and there is my connection. The final connection up here is also ground. So I'm just going to grab a couple of jumper wires here, drop those in, and then I'm going to replace this with a white hookup wire. What I did is I hooked up the system clock to the copy clock, I believe. Let me tone that out just to be, I was so confident I had that. So let me just see how bad I am here. So this one, being the copy clock, should come up here to this, and it does not. Where I believe this one goes is the latch here. Yeah. So that's my system clock, which I've got in the wrong spot. Think this through, Adam. The copy clock is this one. And my system clock, which is coming off the high-speed clock here, is going to go to that connection point there. So I'm looking at this section here of my notes. All right, retone. That means this is actually hooked up incorrectly. Okay, so that's correct. Now this one, this is how I got into trouble before, is connected there. That's correct. All right, let me redo that. So this same signal, which is accurate, needs to be brought down to here. Next up, we need to address the clock. Now, I made a pretty big error here in the way I had this set up until this point when I had to step back and re-debug everything, and that was the oscillator here. The oscillator was running, I think, a little bit too fast for this circuit, at least on breadboard. And so what I've done is I've pulled the high-speed clock off the clock module and fed that in here as the copy clock. Ultimately, that really does need to be an input here, and I have two unused lines here. Realistically, what I'd like to do is stick them in between here, but that would require me to move everything around. And can I do that? I think I can do that, and I think I'm going to give that a shot and just see if I have enough room in these yellow signals here to make room for that. So let me do that. Let me give that a shot here. And then what I want to be able to do is take the high-speed clock from here, run it to this location here, and then pull that down here to feed all the rest of the circuit. But then I'll also need to jump it up here for the high-speed clock up in this area. So let's start here with moving things over. Okay, that change was successful. So now let's tie these together. So here is where my high-speed system clock is coming from, and there's where its new source is going to be. And then if I take this wire, which was a reject from prior, and I set that in here, and it just so happens to fit right down to here, that will then replace those two hookups, and then this one can now be pulled from there. So there's my entry point into this module. I go off to here, I come down to here. Let's test that again. Okay, I'm just about ready to go here to do the same cleanup in the schematic. A couple of things I do want to make sure that I take care of before I go. This wire here has been pulled out of the AB select for the multiplexers, and it's not connected to anything. To avoid confusion, I want to pull that and remove that from the circuit so that it no longer exists. I want to do that carefully because I'm going to do something silly like disconnect a signal here. I've got a similar situation down here where I was driving the reset hold signal from this AND gate, or actually jumped through the AND gate. It was jumped on one of the inputs, and now I can remove that as well. The last thing here is I can connect these two breadboards together and hopefully make this sit a little bit better. So now that's one breadboard, and in doing that, I should be able to now connect these with more permanent connections rather than these flimsy connections here. Okay, and because I pulled that out, I'm going to make one more test here. Now I did update my notes here as to what's what, and then on my large scale format taped together pieces of paper, I did also note what the sequence is for the first 8 here, now that I've made that change. So let's turn around and get that into KiCad now and get this updated. The first thing I want to do is I want to pull my extra latch up here and get it wired up properly. Okay, next up is replacing the proper signals with my not done signal. All right, now let's see if we can get these labeled up properly. Okay, the next thing I want to do is I am not exactly certain when I build this PCB exactly what is going to be required, whether it's the raw system clock or if I can actually put the oscillator on here. So I want to give myself an option between the two. And so what I'm going to do is I'm going to take the raw system clock and make it an input. And then I'm actually going to drop in a 0 ohm resistor here and a 0 ohm resistor there. And I'm going to select this and make it not fitted. Where is that? Do not populate. And make that one not fitted. So that my raw system clock can come in and become the copy clock. But if I want to fit the oscillator, I can do that if I find that the faster oscillator will work here. Gives me an option. Let's see what I broke. I broke nothing. Alright, the last thing I think I want to do, and I've alluded to it before, is this line driver and its LEDs can go away because the clock speed is so fast that it brings no value. So I'm going to remove that from the build. One less thing to try to fit onto a PCB. And let's rerun the rules check. Broke nothing. So I believe this is going to be the final schematic. The last thing I want to start looking at today, and I'm not going to complete it in this video, but several of these signals coming off the actual control module itself are going to need to be demultiplexed. And so how am I going to go about getting that accomplished? Well, at this point, and my plans may change, but at this point my intent is to create a PCB which sits underneath this, which demultiplexes all of those signals and drops those then onto the control backplane so that I can then hook up all the different signals into that. I think that's going to be a bit of a challenge because I don't want to create one for each and every module. I don't want to create 16 different PCBs for this. I want to look at it in such a way that I can hopefully reuse some of this stuff and, crossing my fingers, maybe create 2 or 3 different iterations. Let me show you what I mean. So this is the program which builds that control ROM data. And the first control ROM has 2 groups of multiplexed signals. One is for asserting out onto address bus 1. There are only ever 4 things that can do that. Therefore, it only takes 2 bits in order to multiplex that. But the second one is anything that might assert out onto the main bus. And until I get into the controls for I/O, I only need 5 bits for that. Once I get into the controls for the I/O, I need a 6th bit. So that wraps up what's in Control ROM 1. I have to duplicate all of this for that's on the main bus for the swap bus. So I have to duplicate all of this for the swap bus, leaving 2 bits open. Down here I have 2 bits that are associated with the carry bit select. Well, that pattern looks exactly the same as the Control ROM 1. It could be, in theory, Control ROM 2, which would then handle the carry, 2 bits demultiplexed, and then the swap bus, 6 bits demultiplexed. I still have to deal with address bus 2. There are 12 signals which could be demultiplexed, and I could fit those in 4 bits. But I've got ALU-A and ALU-B, which are both 4-bit demultiplexed. And if I'm careful about how I design that board, I could enable or disable that 4-bit multiplexed so that I have 4 individual signals. So in the next video, I want to work on the PCB for the Control ROM Control. That'll be just a flat PCB, but then I want to start creating backer PCBs for the control modules as I need, and I believe I'm going to need 3 different varieties of those. We'll look at it in more detail in the next video. I want to thank everybody for hanging with me as I've gotten this video prepared. It's taken me a lot longer to release this than I would like, and that's because I've been jumping in and helping my wife out with a project that she's got. She's actually got some hard deadlines that she needs to meet with her project, and me releasing a video is, well, it's on my schedule, and it's more of a soft deadline than anything else. So thanks for hanging with me as I go through this. She still has some more work to do on her project, and I am going to be jumping in and helping her out. That may delay my next few videos a little bit, but I'll get those out as quickly and timely as I can. In the meantime, thank you for your time, and we'll see you again soon.